Okay, welcome to your next video. We're going to be solving equations involving rational expressions. Now, when we have a rational expression in our equation, we basically mean this, that you notice up to this point on these 1.1 videos, we haven't had x in the denominator. Now, when a variable is in the denominator, that's what we mean when we're talking about rational expressions. When a variable is in the denominator, then it's possible for that denominator, right, to be a 0, meaning if I make the value of x a 2 and I put a 2 into this variable, then the denominator is going to be 0. So that's a problem. When I solve this equation, if I end up getting 2 as my answer, I'm going to have to toss that answer. And it's called an extraneous solution. Whenever I multiply both sides of an equation by x, by a variable or any kind of variable, then we're going to have to check our solutions when we're finished. So very first thing I'm going to do is go ahead and proceed by giving myself denominators on every term, just like we did in the previous video with when we had fractions. And then I'm going to look for my common denominator, my least common multiple, my LCM. Now the denominators that I see are 1 and x minus 2. Now my LCM has to be something that includes this and this as factors. So I could just say that I multiply the two together and that's my LCM. Well, 1 times x minus 2 is just going to be x minus 2. So this indeed is my least common multiple that I'm going to use to divide, by which I'm going to multiply both sides. So I'm going to take and multiply both sides. I'm going to go ahead and put it over 1. Okay, and so then you recognize that it's in the numerator, and the x minus 2 is. So I'm going to go ahead and give an extra step that maybe some of you won't use every time, but this is just for clarity. So here we go. We have x minus 2 over 1, and then I have the distributive property. That means I'm going to multiply it by this one. Try to change up my colors here appropriately. And then I have that again that's going to multiply by the second term in the parentheses, okay, which is by the 3. And then, of course, I just have this one. It's going to be multiplied by x minus 2 over 1 as well. Okay, so on the left side, I've distributed my x minus 2 over 1 to both terms, right? That's the distributive property. So there it is there it is there. On the right side, I've multiplied by the same thing. So this, even though it looks like I've multiplied by using that 3 times, it's really just the distributive property. So we understand that. So let's go ahead and simplify. So these are multiplied, and so you notice what we can do. We have x minus 2 in the denominator and x minus 2 in the numerator. Okay, I can't cancel just the x and the x, right? Because those aren't factors. They have to be factors. Can't use terms. So this is going to end up giving me an x. Okay, now on this one right here, the 3 is over 1. So I'm just going to go ahead. I'm not going to do that in my head. I'm just going to write it on the paper. Now, 1 in the denominator means I don't need to write it. Okay, so I just write the numerators, 3 and then x minus 2 right next to it. Again, these are going to cancel, and so I get an x. All right, let's go ahead and finish it up. This is just like the previous video when I was trying to get rid of my fractions. Again, I've gotten rid of the fractions and we're ready to go. 3x minus 6 using the distributive property. I'm going to go ahead and get my like terms together here, which would be 4x. Excuse me. This is going to be 4x minus 6 is equal to x. Notice that my x's are not in one location, so I'm going to go ahead and subtract 4x, get my x's in one location. So I have negative 6 is equal to negative 3x. And then I'm going to finish up. Divide by negative 3, divide by negative 3. And I have x is equal to 2. Now, you remember what we said at the first? If I plug in, I'm going to double check this, right? If I plug this back into the original problem, my value looks like it needs to be a 2. The x value needs to be a 2. So it appears that the solution is 2. However, when I plug a 2 back in, I'm going to have an undefined situation, meaning it's 0 in the denominator. So guess what that means? On these kind where I've multiplied by an x on both sides, whenever I'm multiplying by a variable, any variable, not just x, I have to go back and check to make sure that the solution really works. And when I check, it doesn't work. Right? Doesn't work. And so guess what? I have to conclude that there is no solution. No solution. And what do we say? What kind of equation would be inconsistent? It's an inconsistent equation. All right, so let's go ahead and take a look at the second example. And we have 1 over y minus 2 minus 1 over y plus 2 is equal to 4 over y squared minus 4. All right. The very first thing that obviously you notice that these are rational expressions, and I really do want to get rid of the denominator. So I'm going to go ahead and list my denominators over here. I've got a y minus 2, I've got a y plus 2. Now I'm not going to list this y squared minus 4 as it is. I am going to list a version of it. If I can factor that thing, I'm going to change that into the factored form. All right, that's always what I want to check and see if I can, whoops, minus 2. I'm going to factor it, and then I'm going to list those. Here's the deal though. When I look to list those over here, they're already over here. Right? Now, every one of these denominators, all these parts, have to be in my LCM as factors. Here's what that means. I've got a y minus 2, and I've got a y plus 2. That means that they have to be in there with a multiplication between them, right? They have to be there as factors. So then my LCM is going to be y minus 2, y plus 2. So let's see how that's going to help us get rid of the fraction part of this problem. So I'm going to go ahead and multiply the right side okay, I didn't need that second parentheses. I'm going to do it just like that. I'm going to multiply the right side by that, and I'm going to multiply the left side by this y minus 2, y plus 2 over 1. Now I'm going to go ahead and write it out a little bit more, in a neater fashion here. So I have y minus 2, y plus 2, and all of that over 1. That's going to be multiplied by each of these terms, right? Each term. That one and that one is the distributive property. So here I go. There's that. Now go minus. I'm going to move that equals over. And then I'm going to get, again, write the thing that's being multiplied times the next term, right? Okay, and that's now equals. I'm going to go ahead and put this green one on the left just to be consistent. It's my LCM times what I had on the right side. All right, let's take a look at this. My green LCM got multiplied by this first and second. It also got multiplied by the right side. There they are, there, and there. All right, let's go ahead and take a look. Let's clean this up a little bit. Here's my equals. Keep your equals lined up. It's going to help you if you'll do that. This right here and this right here cancel. Y minus 2, y minus 2, so the right-hand side is 4. How handy is that? Y plus 2, y plus 2 cancel. And I'm left with 1. I do not recommend you try to do that in your head. Just copy what you see. Now notice this minus. I'm going to copy it. Now let's look at this one. Y minus 2, y minus 2. There's a lot of places where you can make a mistake, so I recommend that you go slowly. Now, there's a 1 on the bottom of that, right? That goes in there once, that goes in there once. That's why I'm not writing anything. This goes in there once, once. There's 1s everywhere, so that's why the denominator ends up being 1, and we don't have to write it. All right, let's clean this up a little bit more. The negative 1, that's a negative 1, right? Oops, come on, erase. So I'm going to go ahead and put plus a negative. This negative is going to be distributed. So that's a negative 1y, and that's a plus 2, and that's equal to 4. We notice that we have like terms here. I have a negative 1y and a positive 1y. I add those together. They're actually additive inverses, so I get nothing. Uh-oh. The variable went away. And if you haven't seen the other videos, you should look at them. When I have my variable, I'm just tooling along, minding my own business, trying to solve the problem, and the variable disappears. We stop everything else. We stop. I always draw a little stop sign to emphasize the fact that we stop. And we say, hey, next question is that a true statement or a false statement? Is 4 really equal to 4? It's true. That means that this is all real numbers. This is an identity, and all real numbers work. Okay? So this is an identity. How do we know what the value of x is? Well, the value of x is, we can actually do this, all real numbers. Okay, actually, I think your book would do it this way. Let's go ahead and use the set builder notation in full. This is x such that x is an element of real numbers. I think that's how they'll say it. So don't worry about this part right here. Just remember, this is set theory. I mean, we just have to use this part here. This is x, and that means such that. So we're just saying, hey, any x such that it's an element of the real number system works in this, and it's an identity. Let's go ahead and finish up with the third example. Okay, let's go ahead and do example 3. Okay, trying to shave off some time. All right, there's this last example that I want to do, and again, I see that there are variables in the denominator, and oops, you know what? I almost forgot one thing. Let's go back up to this problem. Oh, almost forgot one thing. It is an identity in all real numbers except, whoa, ho, ho. Glad I remembered that. Remember at the end, we always have to check to see if if our answer really works. And even if we get an identity, all real numbers, we think all real numbers are going to work in this thing. Oh, contraire, I guess, how you say that. Anyway, so look at this. What would I need to put in here so that there would be a denominator? Excuse me. What would be used? What would the y value be? Excuse me. What would the y value be so that the denominator would be 0? A 2, right? And what about right here? A negative 2. So guess what we have to toss? We said that it's all real numbers except, we can actually write it this way, x such that x can't be a 2 and x can't be a negative 2. And that's really all we need to say. We just list what they aren't. We'd also have to do all real numbers except for it can't be a 2 and a negative 2. Okay, so it's true that it's an identity, but there are some restrictions on our identity. You can use any x except for a 2 and a negative 2. Ooh, glad I remembered about that. All right, again, this third example, I look at this problem and I realize that if I get a w as a 1 in my solution set, I'm going to have to toss it because that would be undefined, and we can't have an equation with an undefined situation in it. So let's go ahead and get our LCM, least common denominator. I'm going to make everything a fraction. What I have is this. I have a 1, a 3, and a w minus 1. Now these ones right here, these two ones, cannot be used in the same thing. Basically, this one can't be that one. Okay, so because they have to be there as factors. So here's what I really need. I need the 1 to be there, I need the 3 to be there, and I need the w minus 1 to be there with multiplication connecting them. Right? But technically I really just need this, right? Because we don't need a 1 times something. So this is my LCM, least common multiple. So we're going to do this. We're going to multiply the left side by 3 w minus 1. Now listen to this again. If you're a little bit lost, just replay this because it does make sense. Everything has to be represented as a factor with multiplication next to them, okay? All right, I'm going to write this on the next line showing all my steps. Again, you may not need to do this on your work every time, but I'm doing it for the sake of those who might need it to be a little bit slower. Okay, now it's equal to, and then I'm going to go ahead and put the 3w minus 1 times the 2, right? Now that's still over 1, right? Because I gave it a denominator. If I didn't see it, I give it 1. So now this is that distributive property there. And now let's go ahead and simplify each of these, right? Let's simplify them. So this right here, the 3's are canceled. That goes in there once, that goes in there once. So I really end up with this. I get w minus 1 for that one. These cancel. I get a 3 for that one, excuse me. And nothing cancels on this one on the right, so I'm going to get a 2 times a 3. That's a 6, and then we get w minus 1. Okay, here we go. Let's get all of our like terms together. I see some like terms here. I need to combine them before I move to the right or the left with my thing. I see parentheses. I've got to get that cleared up before I move to the right or the left over the equals. Okay, so it looks okay to me. All right. Okay, so I'm going to get my w's in one location, which means I'm going to do this. Looks okay to do that, right? 2 is equal to 5w. That's a 5. Bad one, but it's a 5. That's a plus 6 now, plus 6. And let's go ahead and finish this up. It's an 8 is equal to 5w. And let's divide by 5, and we'll say that w would have to be 8/5. Now, whoa, let's stop, go back. If I put 8/5 in here, would that cause the denominator to be a 0 right there? Heavens no. So I know that this is okay to leave as my solution. Let me give it the full thing. X such that x is equal to that. There it is. X such that x is 8/5, and by the way, this would be considered a conditional. If you don't understand what I'm talking about, look at the previous video on identifying the type of equation. Conditional. It's conditional. We've double checked, right, to make sure that we didn't. It's conditional. What can w not be? What did we say? Well, it can't be a 1, but we've said that it can only be 8/5, so that takes care of the fact that it's never going to be a 1. Okey-doke. All right, thanks for listening.